Hello friends, welcome to H3 Abundant Academy. In this particular lecture, we will discuss about the stable and unstable equilibrium. So let's begin. So for understanding stable and unstable equilibrium, let us draw two cases. Okay. So let us take a hoop like this in the first case, and in the second case, let us take a hoop like this in the second case. Okay. Now place a ball here, and in the second case, place the ball here. Okay. Now in the first case, we give a slight displacement to this ball. So the new position of this ball will be this one. And in the second case, let us give a displacement here. So the new position of ball will be like this. Okay. Now let us read the statement of stable and unstable equilibrium. So in the stable equilibrium, a body is said to be in stable equilibrium if when slightly displaced from its position of equilibrium. So this is the position of equilibrium. Let us take this as A. This is position of equilibrium. This is case 1 and this is case 2, and this is the position of equilibrium. Okay. So now let us read this. This is case 1, this is case 2. The body is said to be in stable equilibrium if when slightly displaced from its position of equilibrium, the forces acting on the body tend to make it return towards the position of equilibrium. So what are the forces acting on this body? The first one is its weight mg, and the result component of this mg will be, let us take this as mg dash. So this is the result component. So this result component will tend to make this body return to the position of equilibrium. So we have given a displacement like this. So the forces acting on this body, that is mg dash, will tend to return this body to the position of equilibrium. So this is known as stable equilibrium. Okay. But in the second case, this is the displaced position. The forces acting on the body will be mg, and the result part will be, let us take this as mg dash. So the result part of this mg will not tend to make this body return to the original position. Rather, it will displace this further. Okay. So this will not return to the original position. Rather, it will tend to move further. Okay. So this is known as unstable equilibrium. Okay. So let us go back to the statement. So in the case of a stable equilibrium, the body is said to be in a stable equilibrium if when slightly displaced from the position of equilibrium, the forces acting on the body tend to make it return towards the original position. So the forces acting on the body tend to return it towards the original position of equilibrium. Okay. And other way around, the equilibrium of body is said to be unstable if when slightly displaced from its position, the forces acting on the body tend to move the body further away from the position of activity. The forces acting on this body tend to make this body further away from the position of equilibrium. So this is all stable and unstable equilibrium. So now go through the condition for the stable and unstable equilibrium. That is 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h. Okay. So let us discuss this in detail. What is this rho 1 and rho 2? Okay. So now let us take two bodies. So this is upper body and this is the point of contact. This is the lower body. Let us consider the radius of curvature of the upper body is rho 1. Radius of curvature of the lower body is rho 2. Okay. And let us consider the center of gravity of this body at this particular point. This is the point of center of gravity, and this particular point is at a height of h from the point of contact. So the condition for the stable equilibrium is equal to 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h. This is the condition for stable equilibrium, and for unstable equilibrium, This is 1 upon rho 1 plus 1 upon rho 2 is greater than 1 upon h. This is the condition for stable and unstable equilibrium, and h is the height of center of gravity of the upper body from the point of contact. So this is the line of point of contact. So this height is h, and rho 1 is the radius of curvature of upper body. This is upper body, and this is lower body. Okay, the radius of rho 1 is the radius of curvature of upper body, rho 2 is the radius of curvature of lower body, and h is the height of center of gravity of the upper body. Suppose this upper body is a plane surface. Okay, suppose this is a plane surface and lower body is like this. Okay, suppose the lower body is of radius r and upper body is a cuboid and the height of this is a. Okay, so the center of gravity will lie here. Okay, so this center of gravity is at a height of a upon 2 from the point of contact, and this is the plane surface. Upper body is the plane surface, so the radius of curvature of this one will be infinity. So rho 1 is equal to infinity, and this is radius, this is lower body is of radius r, so rho 2 is equal to r, and this is h will be the height of center of gravity from the point of contact. So we have rho 1 is equal to infinity, rho 2 is equal to r. So the condition for the stable equilibrium is 1 upon rho 1 plus 1 upon rho 2 is less than h. So 1 upon rho 1 is infinity, plus 1 upon rho 2 is r, is less than 1 upon h is a upon 2. So 1 upon r is less than 2 upon a. So r is greater than a upon 2. So r greater than a upon 2 is the condition for the stable equilibrium for this particular case. So let us discuss now few questions on this topic. Okay, so we have a uniform cubical box of edge A is placed on top of a fixed sphere. The center of the face of cube being in contact with the highest point of the sphere. What is the least radius of a sphere for which the equilibrium is stable? Okay, so the cubical box is of edge A. So we have a cubical box like this. Okay, is placed on the fixed sphere. The center of face of the cube being in contact. So we have this as a sphere is like this, and this edge of this this cubical box is A. Okay, so the center of gravity of this point will at this cube will lie at this particular point, and this particular point is at a height of a upon 2 from the point of contact, a upon 2. Okay, so a upon 2, this is h, and since this is a plane surface, so we have the radius of curvature of this cuboid will be radius of curvature of this plane surface with respect to this cuboid will be infinity. So rho 1 is equal to infinity, and for lower body this is a sphere. So let us consider the radius of this sphere as r. So since the radius of this sphere we have taken as r, so we have the radius of curvature of lower body, that is rho 2 is equal to r, and the h is a upon 2. So h is the height of center of gravity from the point of contact. So what we have to show is what we have to calculate is what is the least radius of the sphere for which the equilibrium will be stable. So the condition for a stable equilibrium is 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h. Okay, so let us place the value. So rho 1 is infinity, so this is 1 upon infinity, plus rho 2 is r, 1 upon r is less than 1 upon h is a upon 2. So we have 1 upon r is less than 2 upon a. So this is r is greater than a upon 2. So the least radius for which equilibrium is stable is a upon 2. Okay, now let us discuss question number 2. Let us discuss question number 2. A uniform beam of thickness 2b rests symmetrically on a perfectly rough horizontal cylinder of radius a. Show that the equilibrium of beam will be stable or unstable accordingly as b is less or greater than a. Okay, accordingly as b is less or greater than a, this we have to show. Okay, so uniform beam of thickness 2b. So uniform beam of thickness 2b, this is a beam and thickness is 2b. Okay, and let us take a rough horizontal cylinder of radius a. Rough horizontal cylinder of radius a. Okay, so the center of gravity of this beam will lie here. So this point is at a height of, and this is the point of contact, this is the line of point of contact. So this center of gravity is at a height of h, from the this line of point of contact. Okay, and as we have seen couple of minutes ago, radius of curvature of the plane surface is always infinity. So rho 1 is equal to infinity, and rho 2 we have taken as radius of this cylinder is a. So rho 2 will be a. Okay, so for a stable equilibrium, we have 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h, and for unstable equilibrium, 1 upon rho 1 plus 1 upon rho 2 is greater than 1 upon h. Let us apply this, let us put the value here. So we have 1 upon rho 1, so 1 upon rho 1 is infinity, rho 1 is infinity plus rho 2 is a, so 1 upon a is less than 1 upon the value of h is this is 2b, so half of this is b, so this is value of h is b, so this is b. So from here a is greater than b. Okay, so from here we have b is less than a. So for a stable equilibrium the condition is b is less than a. So the equilibrium is stable as b is less. Okay, and for unstable we have to show greater than, b is greater than a. So let us put the value here. So here we have 1 upon infinity, rho 1 is infinity and rho 2 is a. This is greater than, and the value of h is b. So from here a is less than b. So we have b is greater than a. Okay. So for unstable equilibrium we have b greater than a. So let us write down here. So for a stable equilibrium b is less than a, and for unstable equilibrium we have b is greater than a. So for a stable, the equilibrium of beam will be stable or unstable accordingly as b is less or greater than a. So for a stable b is less than a. So for a stable b is less than a, and for unstable this is greater than a. So for unstable this is b is greater than a. Okay, so we will discuss further questions in next particular lecture. Thank you.